All right, good morning. This is our reporting category 1 STAAR review. I think these are old questions from the 2017 STAAR. And all of them except for number 1 have to do with reporting category 1, which is chemistry. For some reason, number 1 snuck into the test without me realizing it, and that's actually a reporting category 2 question. This one goes along with 6.9c, which is in reporting category number 2. Okay, so it says a cook heats a meal in the microwave oven. What energy transformations occur between the microwave oven and the meal? Well, first thing you need to realize is that a microwave has to plug into the wall to work. So we're starting out with the microwave utilizing electrical energy from the outlet. So that already eliminates B and D. So we have to start out with electrical energy. And it's called a microwave oven for a reason. It uses microwaves, which is a form of electromagnetic energy. If you look in 8.8 ABCD, there is a diagram of the electromagnetic spectrum. And microwaves are a little bit shorter than radio waves. So what a microwave does is it takes electrical energy, converts it to microwaves, which is electromagnetic energy, and that electromagnetic energy gets absorbed by your food and turns into thermal energy, which is heat. That's how your food is heated up. So even if you were iffy on the middle step, you know that you should start out with electrical energy and you need to wind up with heat energy because that's what a microwave does. It heats your food. So the proper answer for number 1 should be C. Number 36, a manufacturer selected a metal to use in producing a lightweight button for clothing. A metal that has a density of 2.71 grams per cubic centimeter was selected. Which of the metals was selected? Metal 1, 2, 3, or 4? Well, this requires you to calculate density. You have mass and you have volume. If you look at your formula chart, you do have the formula for density. Density is mass divided by volume. Okay? All right, so let's do some calculations real quickly. All right, so I've got them set up. 22.1 grams divided by 3.00 cubic centimeters, and you get 7.37 basically. Okay, that's metal 1. Metal 2 is 42.0 divided by 4. And that's 10.5. That's way too big. The third one is 9.32 divided by 5. 1.86. That's metal number 3. It's a little bit on the small side. And then the last one is 8.13 divided by 3. Okay. And that's going to give us 2.71. So the metal that we're looking for is metal number 4 because we've got to find one that's got a density of 2.71. Okay. Just so I know you're listening, out to the side of number 36, write the formula for density. Density equals mass divided by volume. All right. Number 42, a student is using colored beads to make a model of aluminum sulfate, Al2SO4 with a 3. Aluminum atoms are represented by blue beads, sulfur atoms by yellow beads, oxygen atoms by green beads. What combination of beads should the student use for the model? All right. Well, how many aluminums do you have total? You have 2. So you should have 2 blue beads for aluminum. Sulfur, remember sulfur is got a subscript of 1 inside the parentheses even though it's not written. Okay, so a subscript of 1 times the subscript outside, which is a 3. So sulfur, you've got a total of 3. And sulfur are yellow beads, so you're going to have 3 yellow. Oxygen atoms are green beads. You have a subscript of 4 inside the parentheses, a subscript of 3 outside, and 4 times 3 is 12. So you've got 12 oxygen beads, and that's going to be 12 green beads. Okay. All right, so you should probably select H because that is the same ratio that we just did. All right, number 2 says, students were asked to identify the location of elements in the periodic table based on clues printed on game cards. So element 1 is a shiny black solid. It's a metalloid, 3 valence electrons, and 2 energy levels. All right, so that tells you that it should be on kind of in the stair-step area. 3 valence electrons puts it in column 13, otherwise known as column 3A. 2 energy levels tells you it's going to be in row number 2. Element 3 is a colorless gas. Most of your gases are in the nonmetal section. Obviously, it's a nonmetal. 8 valence electrons tells you it's either in, not in either. The column it's in is either column 18 or it may be called column 8A. It's the last column. 5 energy levels means it's in row or period 5. All right. Let's see, just based on those 2 we've identified, let's see if we can go ahead and figure out where it is. Element 1, I need element 1 along the stair step. Element 1 is not along my stair step in F, so I know that F's not right. H, element 1 is sort of in the stair step area, so that one's still in the running. For G, element 1 is in the stair step area. And J, element 1 is still in the stair step area. All right, so let's look at element 3. Colorless gas, column 18, that's the last column. So is element 3 in the last column here? No. Is element 3 in the last column here? No. Is element 3 in the last column here? Yes. Is element 3 in the last column here? All right, so now we're down to G and J. All right, element number 2 is a steel gray solid. It's a brittle metalloid. Okay, so metalloid puts it in the kind of diagonal area again. All right, and that eliminates the final answer. I don't see element 2 over here in the diagonal area, so that's not going to be J. It's going to be, your answer is going to be G. All right, number 32, it says, what is the total number of protons, neutrons, and electrons in a cadmium atom that has a mass number of 12? Record your answer and fill in the bubbles on your answer document. Be sure to use the correct place value. Well, first of all, I can look at my formula chart at the periodic table, and I know that cadmium has 48 protons, because that's what makes it cadmium. Because it doesn't give you any information, you have to assume that this atom is neutral. So that means that it's also going to have 48 electrons. And it says it has a mass number of 112. Remember, protons and neutrons together give you your mass numbers. So protons and neutrons are 112, so I've already taken care of protons and neutrons, and really all I have to do is add the electrons to it. So 48 plus 112, let's see if I can do my math right. I get 160. Okay? All right. So that I know you're listening, write down right over here that unless you're told differently, Assume the atom is neutral. Okay, we'll wrap up the backside with another screencast.